हेलो। आज हम जो टुडे वी विल सी व्हाट इज द इफेक्ट ऑफ कार्बन परसेंटेज ऑन माइल्ड स्टील. What will be its effect on the stress strain diagram in case of mild steel? Let us draw a stress strain diagram like this. Right, this is vertical axis, this is horizontal axis, and up to this point this is the limit of proportionality, little bit exaggerated. Now this is like this, and this, and this, like this, something like this. I'll choose another color little bit lighter for defining true stress. It is something like this. Right, now let us draw this. Now this is stress and this is strain. Right, I will not write all the points because here the point is different which I want to discuss. Let me use one another color like this. Oh, color is not selected, like this. Right, and here like this. Right, now what happened when we increase the carbon percentage? When we increase the carbon percentage, the effect is something like this. Now this is the fracture point F, as I had already explained all the points on stress strain diagram, that what are all the points and what they represent. So here I will show that this is fracture strain, means how much strain how much strain happened to the material before failure, before fracture to occur. That is known as fracture strain. Fracture strain, normally it is given in percentage, right? But this is high tensile steel, and here you can see that with the increase in this high tensile steel, mean the carbon percentage is greater than mild steel, right? This is high tensile steel, but at the same time the stress is more. Stress is more. So this material uh, can have can have more stresses. This material can can have more loads. In other words, can have more loads than those which are resisted by mild steel. But however, the material will fail immediately. Material will fail immediately without any sign. So the fracture will be of brittle type. Are you getting my point? Because in mild steel there is an yield plateau over there. So the material will show a sufficient amount of elongation before failure. However, that will not be the case in case of high tension steel, because in high tension steel the carbon percentage is more than mild steel, fracture strain is less than mild steel, and the load which high tension steel can bear is more than mild steel. So the strength of the material is increasing with increase in carbon percentage. However, fracture strain is decreasing, right? So material become more brittle, but a resistance load increased, and this stress can be equal to 1100 megapascal. 1100 megapascal. 1100 megapascal, which here was only 250 megapascal. So based on the application of the material to be used, based on application you will select which material to be utilized. whether high carbon or low carbon. Moreover, Young's modulus has no effect with increase in carbon percentage. This is another observation. This it was the first observation. Another observation is this, that the line OA, this remains same. This line remains same. Only this line is extended up to this particular point. So the region between OA is same. So the slope of this line, if I draw like this, the slope of this line dy by dx will remain same. So the slope is same. So the Young's modulus of material has no effect with increasing percentage of carbon, right? So this is about what is the behavior of the material if we increase the percentage of carbon. Now if we draw this like this, that this is our, say, x-axis, this is strain, this is stress, this is plus coordinates, this is minus coordinates, minus epsilon, and this is minus sigma, right? Now we want to say what will be the result in case of tension and how it will behave like in compression. Like, this is about engineering stress. Now in tension you will find that sigma y is 250 megapascal, but in compression you will find that it is 263 megapascal, little bit more in case of mild steel. All these are values for mild steel, right? And in case of true stress, this is about engineering stress. Here I will write sigma E, right? Sigma E. However, if it is a case of engineering stress, then engineering stress will keep on increasing in this case. However, in case of compression, the engineering stress will be less than the true stress will be less than the engineering stress, and in case of tension, true stress will be more than the engineering stress. As we already know the formula, that true stress is equal to engineering stress into 1 plus something, so it is increasing. However, in case of true stress for compression, it is equal to 1 minus something, which means it is reducing. It is less than this value, engineering stress. It is more than this value in case of tension. So in this lecture we covered what are the effect of carbon percentage on mild steel, and another one is behavior of the material in case of tension as well as in case of compression. So we will meet in next video.